So hi, I'm Kevin Knudson. I'm a professor of mathematics and the associate chair of the math department. And actually, before I get started, I was thinking about the algorithm business that we just heard about. There's a great book, if you haven't read it, it's called Weapons of Math Destruction. And it's great. It's written by Kathy O'Neill, who really knows a lot about algorithms and how they're beginning to rule our lives and how they can be discriminatory and just sort of bad if we don't pay attention. So I really recommend that book. That has nothing to do with what I'm going to talk about, but I heartily recommend it. So I'm here to tell you about what we call the Kronos project. And it started with a question that I was asking, which is, why do students pay to do their homework? I mean, in our courses in the mathematics department, we have very large courses, as you might imagine. In Calculus 1, for example, in the fall, has about 1,700 students in it. And most of those lectures take place in very large rooms. I've taught it in Carlton Auditorium, for example, and the room was full. So it's a bit like performance art. It's not teaching. But part of the course is that students have to do some homework online because, of course, we can't just take up papers that often and grade homework manually. And so we have these online homework systems that various vendors have developed. And they're sort of expensive. And really, the idea is that they get access to an electronic version of the textbook, and then they have these homework systems. And it costs them whatever it costs them, sometimes as little as maybe $60 a semester, sometimes as much as $100. And I started thinking about this, and calculus, as much as I love it and love teaching it and as useful as it is, hasn't really changed in, well, maybe since before the Civil War. Okay? And so the question is, why are students paying a lot of money for information that isn't at all proprietary? It's completely available, open source all over the place, and paying money to essentially do their homework, and it's only maybe 8% of their grade. And so this was the motivating question for me. So luckily, as it turns out, Jim Fowler at Ohio State had also been thinking about this, and I hope to bring Jim to campus next month because he's a real evangelist for this sort of thing. But and the idea that he's developing at Ohio State is, why not open source all of this? There are open source textbooks, so we don't need to be paying for those, and they're perfectly good. I mean, I've looked at several of them. They're all, this will sound awful, but all calculus books are the same from my point of view. I could walk into my office where I have the book that I paid $37 for in 1987, and it's perfectly fine. And so why are we still using new books? But the online homework system is a real issue. And so Jim had this idea to try to develop a system that is open source and works as well and frankly better than a lot of the existing online systems. So it's called Chimera, but so Jim developed this thing. He got an NSF grant to do it. And what it does is it takes LaTeX code. So LaTeX is the mathematical typesetting software. Mathematicians in physics use this. It's something that we just learn to use. It's not difficult to use. I'll show you an example. This is an example of what LaTeX code looks like. So it is, in some sense, a programming language, but I can't program my way out of a wet paper bag, but I can write LaTeX wonderfully. So it's not a difficult learning curve. And so what it does, though, is we use the software to write our papers, and it generates beautifully typeset mathematics. And physicists use it too, of course, because physics is math after all. And so you enter something like this, but what Chimera does is it passes it through various things, and it generates interactive HTML5 pages. So one problem with existing third-party vendors is they're based in Flash, which that's got to go. So they're working on getting rid of Flash, but I mean, this is state-of-the-art HTML5 interactive stuff, and I'll show you how it works. I'll do a demo here in a few minutes. And so this input is just like writing a LaTeX file. Mathematicians can do this very quickly, but anybody can learn to write LaTeX code pretty quickly. I mean, if you just want to do basic mathematics, it's easy. Now, I know you're saying, I'm not a mathematician. I don't need to do mathematics. That's fine, actually. Well, I'll say more about that later. So the short-term goal here with our project, and we got funding from the Provost's office, and from probably somewhere else too, but I'll say the Provost's office, to pay a couple of TAs, one of whom just walked in the door, to get this set up here at UF. And so the short-term goal, so our calculus sequence, calculus 1, 2, and 3 is MAC 2311, 2312, and 2313. We want to get out of these homework, these third-party systems. There are lots of reasons to do this. One is, security issues. When students pass to these online homework systems, they're leaving UF servers. And so these things are storing data about our students. I mean, I think I'm not worried about the security really, but it is an issue where it's passing out to somewhere else, and then we have to bring that sort of thing back. Some of these systems sync up well with Canvas, some of them don't. WebAssign finally has a gradebook integration scheme, but I'm the only one on campus using it because it's new. In the short term, we want to get our courses out of this system. In the long term, we want to get all of our lower division courses out of these third-party systems. So you might begin to think, what are the barriers to this? Well, one is you have to get the server set up. I'll say more about that in a minute. But then you just have to generate problem sets. And what's nice about LaTeX is it is a programming language. And so Jason, our TE over there, has written some code where if you give it one sort of seed problem, he can generate as many as he wants. So in this semester, he and another TA last semester generated 350,000 problems for Calculus 1. And it didn't take all that. It didn't take very much time. And so now we have these enormous problem banks already. In the super long term, and maybe not even super, UF could make the system available campus-wide. Now you might say, I don't need math. That's true, you don't. But LaTeX is agnostic about content. You can write whatever you want in LaTeX. It just typesets things beautifully. It also happens to be able to handle mathematics. But I write, if I need to write essays or whatever, I do it in LaTeX because it's what I write in, because I don't like Word. So it's the software that you use. So you could use this to generate online homework, and you can have free response. You can do all sorts of things that you want, and it has the content doesn't matter. So I don't know how many other disciplines in the room use a lot of online homework systems, but and you can do this in Canvas already. But it's also Canvas has its own issues. So here's the timeline for our implementation. So Jason Knoll, who's a graduate student, he attended this Chimera workshop at Ohio State last summer, and the provost's office generously agreed to send him there, and that got the ball rolling immediately. We have two TAs, one Jason, one some other person. We got the server set up. UFIT helped us get this all going, and then they handed it off to Class IT. Programming work started. We built the problem banks. Like I said, we have 350,000 problems for Calculus 1 already. Canvas integration was dicier than we hoped, but it did work. I'll show you. We did build some homework sets. And the question becomes, students we think, need a textbook. We have mixed feelings about that, but you want them to have access to a textbook. So part of the reason that we have we work with these third-party vendors, is that they have, they're the publishers essentially anymore, and this is how they deliver textbooks. But there are open source texts available, and I've just picked one from OpenStax that UF is a part of the OpenStax project, and there's a perfectly good one that was developed at Rice University that I've been using this semester to great success. My students think it's fine. So this semester, I am teaching a pilot section of Calculus 1. We're testing the system. It's working fine. The students like it, right, Jason? Yeah. So Jason and the other TA, Jeremiah Hocutt, are doing the discussion sections. There's a lot going on in this class. It's a flipped class. I'm using standards-based grading. Everything about this is just crazy experimental, but it's been a lot of fun. So we're also working on building the problem banks for the next course. And we're tweaking what we've got going on. In the fall, I'm going to try the 700 student section in Carleton Auditorium with this to make sure it works. We'll pilot 2312 and maybe start building 2313. And by next fall of 2018, I expect to fully roll this out across Calculus 1 and Calculus 2. And hopefully eventually Calculus 3. The savings for our students, so again, in any given semester, students for these courses pay about $62.50, I think is what they're paying for WebAssign access plus the textbook. So that's 3,000 students per semester. That's about almost $250,000 a semester that our students won't be paying in textbook fees. So that was my main motivation. But I also just like how Kronos works. I like it better than these third-party things. I hope none of the vendors are in the room, but But they work okay, and they're much better than they used to be. But there are issues. So let me see if I can. First of all, here's the Chimera project at Ohio State. So if you're interested in this generically, you can go to chimera.osu.edu. And like I said, Jim Fowler is the faculty member there who really got this going. And he's a ball of energy, and he believes in this, and he's really a great guy. So at this webpage, if you want, you can view their entire Calculus 1 course. It's open source, it's free. You can do whatever. And this is what their course looks like, and I'll click on one of them. Let's click on rational functions. This is a pre-calculus topic, but you scroll down and you begin to see what it looks like. So here's the definition of what a rational function is, and then quickly there's a question. And, which of the following are rational functions? So let's see, that one is, and that one is. I don't know, can I do this? Is that one, Jason? Which definition? Yeah, let's say what it is. Okay. Okay, fine. Let's check our work. Let's see what happens. Hey, I got them right. Okay. But what's nice is, it gives you, you can embed graphs, and it does it using, there's various things that it does. But one thing it does is it plays nicely with Desmos, which is an online free graphing calculator, which is also another wonderful tool. You can look at, so you can embed graphs, you can embed all kinds of graphics, you can embed help features. We see above that, I can't see everything all at once. Well, it's better when you can see the whole thing on your screen. This is getting compressed because of where it is. But the point is, it's a nice interactive tool. So you can build interactive activities for your students. They can work along. This plays the role of their textbook, essentially, at Ohio State. So if you had a textbook written in LaTeX code, you could run it through the Chimera code and turn it all into interactive textbooks online immediately. It's really wonderful. So here at UF, we've called it Chronos because we are adding a few features. So one thing about the Chimera project is, so Jim has this educational philosophy, which I actually agree with, but we're not going to implement here, which is that homework should not really count for anything, right? It should just be one of discovery, and we want our homework to count for some things. So gradebook synchronization is still something we're working on. It wasn't really built into Chimera in the beginning, but Jim, of course, has been open to this idea. What's great about this is it is an open source project. All the Chimera code lives at GitHub. You can, in principle, download it and install it on your own server. And so we've done that. Jason spent most of the fall getting our server set up. But we want this to actually play nicely with Canvas, and we've got it integrated. I'll show you in a minute. And also transmit grades into the gradebook. We're still working on that part. For now, the grades are, it does grade. Students, their answers get marked yes, correct or not. Those data are stored on our server. It's on a local UF server, so that's really nice. Some universities are using Chimera just using Ohio State server, and they're fine with you doing that. In fact, I think they're trying to set up an instance where you could have, if we wanted, ufl.chimera.osu.edu. We don't want to do that. But some universities are going that way because maintaining your own server there are costs associated with that, and someone has to do it. There's a lot of maintenance involved. But we feel like it was worth it. So you can see I'm logged in. If you go to chronos.class.ufl, this is all you'll see. This is just sort of a blank page for the front end. In my own course, this is Calculus 1 that we're running this semester. And so Chimera is integrated as a module. And it's down here at the bottom. And so we can launch, it's like anything that works in Canvas. We can launch our own tool. So I don't know, let's look at the limits practice. By the way, this is the problem that students, I discovered over years of teaching, this is where they fall in calculus. It's not later. Calculus is easy. It's the algebra that gets them there. That's the problem. So here's an example of, here's a limit problem. So let's see, can I do this one? Okay. What's nice is when you start to type your answer in, it's dynamic. So it sort of lets you So if you want to type square root, you type SQRT. I think various things work, right? And it on the right, you'll notice it's dynamically displaying what I think I'm typing. So the student can see in real time if they're typing, what they're typing, what it actually looks like. And let's see, is this right? Yes, it's right. Okay. So so the students in real time get feedback. So I don't know. Let me enter something. So I guess the answer to this is probably supposed to be -10, but I don't know. Let's find out. Let me put in something like 6 and see what happens. Nope, I got it wrong. Okay, but maybe I can try it again. This is just set up as a practice assignment, so we can give students infinite number of attempts. You can limit the number of attempts. You can put tolerances on the answer. So for example, if there's a numerical answer involved, and you want to say, if they get the first 2 decimal places correct, it's okay. That works. It's symbolic. If the answer is supposed to be symbolic, it reads that, and it's very flexible with respect to how it does it. I think the answer to this is -10. I haven't thought about it closely. Nope, I didn't get the right thing. What's the answer, Jason? It's the derivative of x minus 1 squared at, so it's 2x. Okay, anyway, whatever. I need a piece of paper. Anyway, the point is, I really can't do calculus. But it's really a wonderful tool. And you can have these more interactive questions. For example, does this polynomial have a root in the interval between 0 and 5? I claim yes, it does. But why is this true? Okay, and then there are various reasons. And the answer, I looked at this, I cheated before I looked at this one. That's correct. The intermediate value theorem assures that you get a root of this thing. So you can build as many questions as you like. It's really, and students, if they decide they want to try again, they can erase all of their work. It can be saved. Since I passed through Canvas, this really is my Canvas profile. So all that communicates with the server, and it all gets passed back and forth. So it's all functioning wonderfully. So what I would say is, if you have an interest in this, I mean, it exists. Like I said, there's no grade syncing yet, but that's a feature that we're working on, and it should be ready to go by the fall. But you can always, by you I mean someone, can always access the data. We have very limited access to the server, of course. We don't want anybody logging into the server. Yeah, question? Mm-hmm. Yeah, and what's nice about this is, if you're deliberate about it on the front end, creating an assignment in Kronos is very easy, because if you, for example, say you want, this is particular to mathematics, but you could do it in any discipline. If you have questions that you say you want a question about topic X, topic Y, and topic Z, if you tag them, you can create tags inside the database so that you can just, you want to create an assignment, you just say, give me all the questions that have topic X, Y, and Z in them, and it pulls them. If you want, you can tag. This is the beauty of LaTeX. You can make it anything you want. You can tag it however you want. So yeah, so you have particular learning objectives that you want. You can tag all of your questions in the database with that, and then to create an assignment, you can pull all of them, or as many as you want, or and then choose what you like. So LaTeX is a very powerful tool. And what's nice is, you might think this takes a lot of storage and all that but it doesn't really store anything on the server. It's storing LaTeX files, which are just text files. So the storage requirements are really pretty minimal. It's fast. It loads quickly, and it's really a nice system that we're like we have to build out a lot more features. But there's ways to add interactive help. There's ways to link to all sorts of things. You can so you could link out to videos if you have a particular problem that you want to maybe you've got a video that you explain how to solve this type of problem. You could link it out to that if you want. There's a lot we could do. You have a question? Yeah. Yeah. Mm-hmm. Yeah, so we haven't done that yet. That's the thing. But you can make it anything you want. So if we wanted to create videos, for example, of people working out examples of maybe not that exact problem, but something like it, you can link straight to that. You can link to documents. You can have it pull up a PDF. You can link to sections of a text, which is another reason to use online open source texts, because then you can link to specific sections of those things. And that's how, so that is part of what we're going to do as we build out more features. Our first goal was just to get this thing up and running so that students could be doing their homework. Mm-hmm. No, so far, so since this was developed in the math department at Ohio State, that's been their focus. Even at Ohio State, it's just been in the math department. But lots of math departments around the country are looking at this. Colorado State's really jumped on board in a big way, and other universities have as well. But it's really up to you. I mean, if someone's willing to pay somebody, I mean, it just takes a little time to build out problem sets. It could actually work in any discipline. And like I said, LaTeX doesn't care about the content. It's wonderful for writing mathematics, but it works. It's just an ordinary, typesetting software. So yeah, nobody's using it in other disciplines yet, but it's sort of obvious that physics would be able to use this. But even I think in chemistry, you could easily embed molecular diagrams. That shouldn't be too big of a problem. But come on, economics, sociology, whatever. I think. If you have a need for an online homework system, and I mean you already have Canvas, so maybe in non-hard science disciplines, maybe Canvas works well enough. I don't know. I've never had to use it. Yeah, it was part of the design of the software to keep track of these analytics, where really across each problem, how are students doing here? How does that affect how they do in the future? So a lot of thought went into it in the very beginning. Yeah. It's HTML5. Yeah, so for example, WebAssign is Flash-based, but this is all HTML5. Yeah, and I think Jim even thought about accessibility issues on the front end. So yeah. That's a little trickier in mathematics, because how do you make a graph accessible? I know there are ways to do it, but yeah, it's a concern that is floating out there. But WebAssign isn't. I mean, those things, they claim to be accessible, but whether they are or not is subject to interpretation. So yeah. Any other questions? We're really excited about this project, and so I said super long term. Anyone at UF, really super long term. This could be an SUS project. It seems to me that once we've sort of worked out all the kinks, it's open source. We're happy to share what we've learned and what works. If you can get it installed at your own campus, and we can share our problem banks. I mean, so our problem banks are those are the only things that are locked down. Those are password protected at GitHub. But the Chimera code itself and any improvements that Jason has been making to it. Those are open source at Git, and it can be a very powerful money-saving tool for our students. That's another thing. Yeah, I'm not familiar with that platform. So here at UF, we mostly use WebAssign and MyMathLab through Pearson, and as WebWorks is another popular one that some people have used in the past. But yeah, actually, we can talk about that offline. Yeah. Okay, well, if anybody's interested in Kronos, the server exists, and we're happy to share, and thanks for coming. At the end of the day, right? You made it all day.